Welcome to our tutorial video on the ECD-4-nano dilatometer. In this video, we'll guide you through the complete setup process for electrochemical measurements. We'll start by covering everything you need before using the device for the first time. Then, we'll walk you through the steps required before each experiment. Let's begin with the initial setup. First, remove the transport locks from the dilatometer. Unpack the test cell and place it on a flat surface. Unscrew the two nuts that secure the sensor unit. Then, lift it off the cell base and use the supplied Allen key to release the locks. In the next step, we will complete the preparation of the sensor unit. This requires the add-on weights and the load unit. Both serve to increase the force applied to the cell stack. Attach the magnetic weights to the corresponding holder on the front and back. Mount the load unit to the sensor unit. The springs must rest on the plates at the front and rear, and the edges should be aligned flush with one another. Tighten the screw hand tight to fix the load unit in place. Now connect the displacement sensor. Push the sensor cable in until it clicks. We recommend leaving the sensor cable connected at all times once it has been connected to the sensor box. We'll now set up the full measurement system, including the potentiostat and sensor box. Let's go through the connections step by step. Let's start with the PAT Tester X8 potentiostat. First, connect the controller to the test channel using the USB cable. Then connect the cell cable to the sub-D port on the PAT channel and the cell port on the PAT Stand 1 docking station. Add the sensor box to the setup by connecting the sensor-to-sensor box cable to the aux-in port of the PAT stand. The other end goes into the signal out port on the sensor box. Connect the sensor cable we inserted into the ECD earlier to the sensor input on the sensor box. We can then connect the sensor box to the power cable. As a general rule, we recommend switching on the sensor box only after the sensor cable is connected. Before running your first measurement, we recommend checking the displacement sensor. Begin by preparing the cell base. Loosen the locking screw on the cell cap slightly using the supplied torque wrench. Then, Unscrew it by hand until you can remove the cover by turning the bayonet lock. Remove the sealing ring or the orange dummy ring that came with the device. Place the spacer disc in the center of the frit flange unit. Fold the lever down to the stop to set the frit flange to the correct height and hold it there. Using the supplied torque wrench, gently tighten the clamping screw. Pay attention to the low tightening torque while doing this. Finally, flip the lever back up. Place the sensor unit with its attached cable onto the cell base and secure it using the 2 nuts. Then insert the ECD into the socket on the PAT stand 1 to connect it to the PAT tester potentiostat. Check the dilation value in the EL software. It should be close to 0. Lift the sensor slightly, then slide the control plate under the measuring tip. Check the value again. You should see a change of around 50 micrometers, within a tolerance of plus or minus 10%. If so, the sensor is working correctly. Next, let's adjust the applied force on the cell stack. In addition to the add-on weights, you can fine-tune the load using the dial on the load unit. Turning the dial clockwise increases the load to approximately 15 newtons. The final step in the initial setup is calibrating the dilation sensor using the ECD-4 centering device. A connected PAT tester X8 is required. Mount the centering device on the PAT stand 1 docking station by removing the 2 connector adapters on the left-hand side and attaching the device in their place. Next, disconnect the sensor box cable from the docking station's aux-in port. Connect the centering device plug, then reconnect the sensor box cable to the remaining input. This ensures the signal is properly routed. Insert the ECD-4-nano into the socket on the PAT stand 1. Push until you hear it click into place. We can now see the lower LED on the centering device light up. This means that the dilation sensor is set too low. To adjust the sensor calibration, first release the sensor lock. Then turn the adjustment wheel counterclockwise to raise the sensor until the middle light on the centering device comes on. The dilation sensor is now set to the 0 position, with a margin of plus or minus 20 micrometers, which is perfectly sufficient. Make sure to close the lock again after calibration. The ECD-4-nano is now fully set up. Next, we'll go through the steps required before each measurement. Start by disassembling the cell base in preparation for a new experiment. This step is performed before entering the Glovebox. Cleaning should already be completed, as described in the user manual. Only the cell base is needed for the following steps. The sensor unit can remain in the climate chamber, and the sensor cable should stay connected. We start by removing the screw cap. Loosen the thrust screw with the torque wrench, then continue loosening it by hand and remove the cap. If present, remove the sealing ring. A new one will be installed later. Loosen the screw securing the frit flange unit. Then use the tweezers to lift the unit out. Now dismantle the frit flange unit. Turn it over and unscrew the thrust screw by hand. Remove the glass frit. Then remove the reference ring. If this is the first time you are disassembling the dilatometer, you will find an uncoated dummy pre-installed. Push out the spring-loaded plunger with the tip of tweezers. Finally, remove the plunger from the frit sleeve. All the parts have now been disassembled and are ready to be placed in the glove box. Please note the different drying temperatures. The parts of the frit flange unit must be dried in a vacuum oven at 120 degrees for at least 12 hours. The glass frit needs a higher temperature of 180 degrees. All other parts of the cell base must be dried at 80 degrees. We will now assemble the cell in the glove box for a half-cell measurement. Begin by assembling the frit flange unit. Carefully insert the reference electrode into the frit flange and align it with the guides. Now, add the glass frit with the narrow end facing downwards. Then, insert the frit sleeve. Put the counter electrode on top of the glass frit. We recommend using a diameter of 9 millimeters and a thickness of 0.3 millimeters or thinner. Insert the piston. Attach and tighten the thrust screw. Finally, turn the assembly around and check that the glass frit sits properly in the opening of the frit flange. Now insert the frit flange unit into the cell base. Align the opening with the pin. It should slide in easily. You can test the correct positioning by pressing the unit down with light force, and it should pop back a bit. Using a pipette, add about 240 microliters of electrolyte. Do not exceed 250 microliters, as this may cause overflow and contaminate the cell base. Then place the working or upper electrode on top of the glass frit with the active layer pointing downwards. Now place the spacer disc on top. It should completely cover the working electrode. Fold the lever down to the stop and hold it there. Gently tighten the clamping screw using the supplied torque wrench. Pay attention to the low tightening torque. The frit flange is now locked in place. Flip the lever back up. Now you can fit a new sealing ring. Prepare the screw cap by attaching the membrane. Ensure that the membrane's flat side is facing upwards, and be careful to touch it only at the edge, not the center. Insert it into the screw cap and press it down gently until it snaps into place. Place the screw cap on the cell base. Fasten it first by hand, then with the torque wrench. Remove the cell base from the glove box. Attach the sensor unit and secure it. All right, assembly is done, and the dilatometer is now ready to measure the half-cell expansion. Finally, let's take a look at how to assemble the ECD-4-nano in full cell mode. We'll start in the Glovebox again. The reference electrode isn't needed in this setup, so I'll set it aside. Instead, we need the metal plunger from the full cell kit. It replaces the glass frit. I'll remove that as well. Okay, now insert the metal plunger into the frit flange with the narrow end facing upwards. Then attach the frit sleeve. If installed, detach the plunger from the plunger assembly. We don't need that for full cell mode either. Insert the plunger assembly into the frit sleeve. Finish the frit flange assembly by putting on the thrust screw and tightening it by hand. Turn the assembly around and verify that the plunger is seated correctly. Now insert the frit flange unit into the cell base. Align the opening with the pin. It should slide in easily. Gently press down on the unit to test it. It should spring back. Then place the adjustment tool on the frit flange. Place the lower electrode on top of the plunger. The active layer must point upwards. Remove the adjustment tool and place the 10 mm diameter separator on the electrode. Put the adjustment tool back in place, then add about 40 microliters of electrolyte using a pipette. Never use more than 50 microliters to avoid spillage. Place the upper electrode on top of the separator with the active side pointing downwards. Then remove the adjustment tool. At least one electrode should have a smaller diameter than the separator to prevent a short circuit along the separator's edge. Insert the spacer disc. It should completely cover the upper electrode. Now fold the lever down to the stop and hold it there. Gently tighten the clamping screw using the supplied torque wrench. Pay attention to the low tightening torque. Then, flip the lever back up and insert a new sealing ring. Now we'll prepare the screw cap by attaching the membrane. Ensure that the membrane's flat side is facing upwards, and be careful to touch it only at the edge, not the center. Insert it into the screw cap and press it down gently until it snaps into place. Place the screw cap on the cell base. Fasten it first by hand, then with the torque wrench. Remove the cell base from the Glovebox. Attach the sensor unit and secure it. The ECD-4-nano is now ready and set up for testing in full cell mode. This concludes the main steps for using the dilatometer. Thank you for watching, and see you next time.